Imagine the ground beneath you begins to tremble. Walls crack and crumble. Buildings sway and collapse. This is the terrifying reality of an earthquake, a sudden, violent shaking of the Earth's surface. But what causes these destructive events? How do they impact our planet and our lives? Earthquakes are not random occurrences. They are the result of the Earth's dynamic nature, a release of energy within the Earth's crust. This energy release is caused by the movement of massive pieces of Earth's outermost layer, called tectonic plates. These plates are in constant motion, albeit very slow, generating immense pressure along their boundaries. The Earth's tectonic plates fit together like a giant jigsaw puzzle, but their boundaries are not smooth. These boundaries are where most earthquakes occur. There are three main types of plate boundaries: divergent, where plates move apart; convergent, where plates collide; and transform, where plates slide past each other horizontally. Along these boundaries, stress builds up over time as the plates push, pull, or grind against each other. This stress is stored in the Earth's crust until it exceeds the strength of the rocks, causing a sudden rupture along a fault line. The point where the rupture begins is called the focus, while the point directly above it on the Earth's surface is the epicenter. When an earthquake occurs, the stored energy is released in the form of seismic waves that travel through the Earth. These waves cause the ground to shake and vibrate, resulting in the destructive effects we associate with earthquakes. There are three main types of seismic waves: P waves, S waves, and surface waves. P waves, or primary waves, are the fastest and can travel through both solids and liquids. S waves, or secondary waves, travel slower and can only travel through solids. Surface waves, as their name suggests, travel along the Earth's surface and are responsible for most of the damage caused by earthquakes. The most immediate and visible effect of an earthquake is ground shaking. This phenomenon is the result of the sudden release of energy in the Earth's crust, creating seismic waves that travel through the ground. These waves cause the ground to move in various directions, leading to the shaking that we feel during an earthquake. This shaking can range from barely perceptible tremors to violent vibrations capable of toppling buildings and bridges. The severity of the shaking can cause significant structural damage, leading to the collapse of infrastructure and posing a serious threat to human life. The intensity of shaking depends on several factors, including the magnitude of the earthquake, the distance from the epicenter, and the local geology. Larger magnitude earthquakes release more energy, resulting in stronger shaking. Proximity to the epicenter also plays a crucial role, as areas closer to the source of the earthquake experience more intense shaking. Additionally, the type of soil and rock in the area can amplify or dampen the seismic waves, affecting the level of ground movement. Besides ground shaking, earthquakes can trigger other devastating events, such as tsunamis, landslides, and liquefaction. These secondary hazards can cause even more destruction and loss of life than the initial shaking. Tsunamis are giant waves caused by underwater earthquakes that can travel thousands of miles across oceans, causing widespread destruction along coastlines. These waves can inundate coastal areas, sweeping away buildings, vehicles, and anything else in their path. The sheer force of a tsunami can lead to catastrophic damage and significant loss of life. Landslides occur when unstable slopes fail due to ground shaking, burying homes and blocking roads. The movement of large amounts of earth can destroy entire communities and make rescue efforts extremely difficult. Landslides can also disrupt transportation and communication networks, further complicating disaster response. Liquefaction happens when water-saturated soil loses its strength and behaves like a liquid, causing buildings to sink and underground structures to float. This phenomenon can lead to severe damage to foundations and underground utilities, making recovery and rebuilding efforts challenging. The effects of liquefaction can be long-lasting, impacting the stability of the ground and the safety of structures for years to come. Measuring the unmeasurable, quantifying earthquakes. Scientists use seismographs to detect and record the seismic waves generated by earthquakes. These instruments produce seismograms, which provide valuable information about the earthquake's magnitude, location, and depth. The Richter scale, once widely used, has largely been replaced by the moment magnitude scale as the standard measure of an earthquake's energy release. The moment magnitude scale is logarithmic, meaning that each whole number increase on the scale represents a tenfold increase in the amplitude of the seismic waves and approximately 32 times more energy release. For example, a magnitude 7.0 earthquake releases about 32 times more energy than a magnitude 6.0 earthquake. Predicting the unpredictable early warning systems. Despite advances in seismology, accurately predicting earthquakes remains a significant challenge. Earthquakes are complex natural phenomena, and their occurrence is influenced by a multitude of factors, making precise predictions difficult. Scientists can identify areas at high risk of earthquakes based on historical data and geological studies. By analyzing past earthquake events and studying the geological features of a region, they can determine which areas are more likely to experience seismic activity. However, pinpointing the exact time, location, and magnitude of a future earthquake is still not possible. The unpredictable nature of earthquakes means that even with the best technology and data, we can only estimate probabilities rather than provide exact forecasts. However, researchers are making progress in developing early warning systems that can provide seconds or minutes of advance notice before the strongest shaking from an earthquake reaches a particular location. These systems are designed to detect the initial, less destructive seismic waves, known as P waves, which travel faster than the more destructive S waves and surface waves. These systems work by detecting the P waves, which travel faster than the more destructive S waves and surface waves. When P waves are detected, the system can send out alerts to areas that will soon be affected by the more powerful shaking. While this warning time is limited, it can be crucial for taking protective actions, such as seeking cover, shutting down critical infrastructure, and initiating emergency responses. Even a few seconds of warning can make a significant difference, allowing people to move to safer locations, stop machinery, and prepare for the incoming shaking. This early warning can help reduce injuries, save lives, and minimize damage to critical infrastructure. Preparing for the inevitable steps towards safety. Living in earthquake-prone areas requires a proactive approach to safety. Earthquakes can strike without warning, causing widespread devastation. Therefore, it is crucial for residents in these regions to be well prepared and informed about the necessary precautions. Preparing for an earthquake can significantly reduce the risk of injury, property damage, and loss of life. The aftermath of an earthquake can be chaotic and overwhelming, but with proper preparation, the impact can be mitigated. Communities that invest in preparedness are more resilient and can recover more quickly. Here are some essential steps individuals and communities can take. Secure your home. Ensuring that your home is structurally sound and equipped with earthquake-resistant features is a critical first step. This includes reinforcing the foundation, walls, and roof to withstand seismic activity. Secure heavy furniture and objects that could fall and cause injury. Develop an emergency plan. Heavy items such as bookshelves, televisions, and appliances should be anchored to walls to prevent them from toppling over during an earthquake. Additionally, creating a comprehensive emergency plan with your family is essential. Create a family emergency plan that includes evacuation routes, meeting points, and contact information. Prepare an emergency kit. Your plan should outline clear evacuation routes from your home and designate safe meeting points where family members can reunite if separated. An emergency kit is also vital. Assemble a kit containing water, food, first aid supplies, a flashlight, a radio, and other essential items. Participate in drills. Your emergency kit should be easily accessible and contain enough supplies to last at least 72 hours. Regular participation in earthquake drills helps reinforce safety procedures. Regularly participate in earthquake drills to practice safety procedures and familiarize yourself with the appropriate responses. Support earthquake-resistant construction. Drills are an excellent way to ensure that everyone knows what to do when an earthquake occurs. Advocate for and adhere to building codes that prioritize earthquake-resistant design and construction. Supporting and adhering to stringent building codes that emphasize earthquake-resistant construction is crucial. These codes are designed to ensure that new buildings can withstand seismic forces, thereby protecting lives and property. A force of nature. Respecting the Earth's power. Earthquakes are a powerful reminder of the dynamic nature of our planet. While we cannot prevent them, understanding the science behind earthquakes, their potential impacts, and the importance of preparedness can help us mitigate their devastating effects and build safer, more resilient communities. By respecting the Earth's power and taking appropriate precautions, we can live in greater harmony with the forces that shape our world.